In this lesson, we're going to look at regression analysis. Regression analysis is a process that's used to mathematically define the relationship between two variables. We end up using linear regression in this course, and that is to find the line of best fit that goes through our data points. So, as it states here, the regression line then is the line that best fits through the data set. The regression equation is the equation of that line. Now, if you remember back to your algebra days, we used y is equal to mx plus b, where m is your slope and b is your y-intercept. Now, in our calculator, I'm going to let this out of the bag, get the cat out of the bag. Our calculator, when it looks at our data, it's going to have the value b, which stands for the slope, and a plus a, and that's your y-intercept. That's the way the BA2 Plus calculator works. So make sure that you commit that to memory. So how does this work moving forward? If we figure out that the correlation coefficient indicates a significant relationship or a strong relationship, the next part of this process is to find the model, determine what the line of best fit is, right? And once we have that, then we can answer questions about the population through the idea of a prediction interval, which we'll talk about as we move along, which is really a confidence interval. Now, what process is used to come up with this line of best fit? It's the least square criterion that's used. And the straight line that best fits the set of data points with the smallest possible sum of the squared errors is the line of best fit. Okay, so what does that mean? So if we have our data points put together in our scatter plot, and then we try to fit a line through those points so that it has the least amount of error, well, remember that the error is the distance from each of the points to the line. And what we do is we take this error and we square each of those errors. So you can picture this turn into a square. We do the same with all of these, right? And so we end up with the following picture. All right, so this represents our error from the point to the line squared. So each of these boxes is actually an error squared, right? All of those. So if we add the sum of these squares and we make it so that this line is shifted in such a way that these squares become smaller and smaller. So you can picture, for instance, if we pivot, suppose we pivoted this and we move this up a little bit, you'll see that if the line changes the amount of error, this error becomes smaller. This error here looks like it gets a little smaller, but this error here actually has increased. And this error, well, it looks like it may have gotten a little bit less. But the line moves in such a way that these squares change shape, right? They get, but in such a way that it's the smallest possible area for these squares. Right, so that's the technical aspect of what's going on behind the scenes. Now, our calculator takes care of all of this through the formulas that are built into it. So all we have to make sure is that we understand what the data points are in terms of dependent, independent variables, and make sure that we correctly input our data, and then take the numbers and tell the story about those numbers. So with that said, let's take a look at our first example. So in this case, we have a data set. We have sales and ads per week. And the first question asks, which is the independent and the dependent variable? So we look at this and say, do sales depend on ads, or do ads depend on sales? Well, you can see that the sales depend on the number of ads. You advertise more, your sales should go up. So this is the independent variable, and sales is your dependent variable. So independent is ads, and dependent is sales. Next, it asks to create a scatter plot. So I'm going to take this data and I'm going to put it into Excel. So here is our data. Now, what I'm going to do is I'm going to change this around so that our independent variable is first, and then our dependent variable is second. Next, what I'm going to do is, as I did before, I'm going to select my data, and I'm going to go Insert, Scatter Plot. Oh, my mouse is having a mind of its own. And there we go. There's the relationship, and we should put our labels on the axes. So that's ads per week. And the sales, and we'll put dollars. Okay, and we should also include our title. We'll say ads versus sales. And I'm going to move this chart chart. And hit enter. And there we go. So now we have our scatter plot put together. We'll come back to this in a minute. So next, let's go and answer some more questions. It asks to determine the correlation coefficient rounded to 4 decimal places and explain the findings. So once again, let's go back to our data set and let's put that into our calculator. So now that I have my calculator out, once again, I go second data, second clear, and I'm going to put my XY pairs in. So 2, enter, scroll, 3,500, enter, scroll. So second data point is 3 ads, enter, scroll down, 5,500, enter, scroll down, and so on and so forth. Okay, and now that I have my data set, I'm going to start from scratch and go down and make sure everything's correct. And it looks good. Okay, so now we go and we find the correlation coefficient. Once again, that there is second stat. Make sure you're in linear mode. Scroll down until you see your R, and it looks like it's quite strong. So the R value is 0.9890, so it's a strong positive relationship. Correlation. And what does that mean? Once again, as ads increase, sales increase. Right? That's what that tells us. Next, it says determine the linear regression equation, round it to 4 decimal places, and explain your findings. Right? What the values represent. So I'd mentioned that our calculator gives us y is equal to bx plus a, where b is your slope and a is your y-intercept. So going to our calculator once again, if I bring this up, I scroll back and there are 2 values, and this is what I'm going to use to write down. So y is equal to -357.5 0.1428571 plus 2,000. That was your B. So you put your X, right? So A and B. I changed the order, but as long as we make sure that the X is next to the slope, then everything's fine. Next, I'm going to round, and this is minus 357.1429 plus 2000x, and that's 4 decimal places, as was mentioned, right? Round to 4 decimal places. Next, what we're going to do is we're going to predict a value when you have 4 adds. In other words, let's put in x equal to 4 and see what y becomes. So y is equal to minus 357. I'm going to use the unrounded value because that's what your calculator would do, plus 2,000 times 4. And you can see mathematically this gives you $7,642.86 when we round to 2 decimal places. So let me just put 2 decimal places here. And I'd specify how to best round. Okay. Now, our calculator also has a built-in function. I'm just going to put x prime, y prime here. And we're going to put x is equal to 4, and we're going to try to find out what y is. So if you scroll down next, and you have your x prime here, if we put in 4, go 4, enter, and scroll down, and hit compute, then you have the exact same value. There we go. All right, so we can use our calculator, our shortcut here, to figure out what the value is. In a test situation, as long as the values are correct that you inputted, this is all you really have to do to answer any question about prediction. Now, let me go back to the scatter plot. And we're able to actually put the regression line on here. If we go right-click, add the trend line. So I right-click on a point, it will put the trend line, and we want the linear value. And there we go. And we can also add the r squared and the equation. So here's the equation, and here's the r squared, our coefficient of determination. And let me make that a little bit bigger. My calculator's, or my computer's not cooperating today, as you can see. I'm going to make these a little bit bigger. There we go, home. And let's make those larger so we can see what they are. There we go. Actually, let's make it really big here. There we go. So here's the equation, as was mentioned, to 2 decimal places. And here is r squared, our coefficient of determination. I wanted to add as well that our chart, our line, doesn't go beyond what our data is given. So we weren't given data less than 2 adds, and we weren't given data for greater than 8 adds. So we can only use this model between the data points that were given, in this case x being 2 to 8. So we can use this to predict between 2 and 8 adds. Now our question said, what is the predicted value for 4? Well, if we go to 4 and then go across, there's that 7,000 and change. So that's how this graph is read. That's it. I'm going to pause and I'm going to go to the next example.